Building apps is a useful practice as a sophisticated way to parameterize your model, making it more powerful and easier to pick up at a later date. You can also share these apps with non-COMSOL multiphysics users by creating packaged simulations and/or results viewers. Finally, you can link to legacy code in various code types. In this video, we will show you how to build a simple app, demonstrating the various tools you have at your disposal in building apps, centered around the form editor, which controls the user interface design, and the method editor, which controls the programming aspect of building apps. We will then show you how to run apps, which can be done through either COMSOL multiphysics or COMSOL server. So here we have the busbar tutorial model opened up, and we've made a few minor changes to the model. We have a volume maximum node, which evaluates the maximum temperature in the copper busbar domain. And we also have a report node, which generates a brief report of the model. So here we're dealing with a fairly simple model, but as your simulations become increasingly more complex, there can be a lot going on among the physics definitions and other model settings. A way that we can simplify all of this information and make it more accessible to others is by converting our model into a simulation app, which we can do by using the application builder. And clicking that button brings us here to the application builder user interface. If I click the model builder button, that brings me right back to the model builder. So this is a way you can switch between the two similar builder environments. Here in the application builder, we have 6 main nodes that we'll be working with in developing a simulation app, and these are the main window, forms, events, declarations, methods, and libraries. And these are all also available in their respective sections in the Home tab in the ribbon. For both the form and method editor, separate tabs appear in the ribbon, which we will see later on. Here right now you can see we have a preview window open, which typically shows us a preview of the currently selected form or method that we're working on, but since we have none yet, we can go ahead and toggle this off. So to start a brand new app, the first thing we can do is click the New Form button, which opens the New Form wizard. Here we can add inputs to our simulation app. Let's go with the length of the busbar, the width of the busbar, and the applied voltage. And let's also include the derived value for the maximum temperature of the busbar as an output in our simulation app. For the graphics, let's include a plot of the temperature results. And then for the buttons, we definitely want to include a button for the user to compute the study. And here to the right, we can see a preview of how that app is coming along. So upon clicking OK, we have access to all the items which we just added, which I'll also refer to as form objects. And we can start to click and drag and drop them where we want them to be. Perhaps we want the compute button here. Let's separate this output value. And let's enlarge the graphics window. If we click the test application button, you can see we immediately have a working app available. So let's change the width to 7 and the length to 10 and compute the model. We can see a slight change in the maximum temperature, and we have an updated temperature plot with the results. Perhaps our users would want to see the geometry updated before computing the model. Previously, we just went through adding form objects to your app through the form wizard, but you also could have added any of these items manually using either the editor tools window, which would be the quick and easy way to add a form object that we will be demonstrating a little later on, or through using insert object, and then choosing from the variety of options available here for any additional functionality to your app. We want to include a button to update the geometry, so we will click on button. And let's move this to the side. Let's update the text, update geometry, and let's change the icon to the geometry icon, increase the size of it to large to better match the compute button. And now that we've handled the appearance of the button, we specify the action that will be performed when we click on the button. In our model, we can go into our model component and then select the geometry node and click plot. So we have this plot, but now we need to specify where the display of this geometry appears. And we'll want it to appear in our graphics object. So what we can do is click Edit Argument, and then under Form 1, our graphics window here, we can use as the argument, click OK. And so now, when a user clicks this button, it shows the updated geometry of the bus bar and displays it in the graphics window. Alright, so we've added this useful functionality for the user before they solve the model. So perhaps we can also add something that would be helpful for the user after solving. If we return to the model builder, you'll recall that we have a report 1 node which generates a brief report of the model. Perhaps we'd like for this to be available to users. So we can go in the application builder, and instead of manually inserting an object and editing the settings, what we can do is utilize the editor tools window, which allows us to add form objects or groups of form objects to our form with predefined settings. So we can scroll down and go to the report 1 node and click button. Now we have a button with all of the settings automatically implemented that enables a user to create a report. So here in the app we have 3 buttons which we've added 3 different ways. The compute button was added while using the new form wizard. The update geometry button was added using insert objects, and the create report button just now was added using the editor tools window. So these are all different ways that you can add buttons and other form objects to your app. Once again, if we return to the model builder, with respect to the report node, you can see in our model, we have the option of exporting either an HTML file or a Microsoft Word document. And perhaps we want to make this option available for our users. If we return back to the application builder, under our report node, you can see we don't have any options available with which we can do that. So what we can do is we can return to the model builder, and in the developer tab of the ribbon, we can click the data access button. From here we can select by clicking in the checkbox for which settings we want to make available as an input or output for our users. And you'll notice that all of the checkboxes were deselected by default because, as you can imagine, for this node, among all the other nodes in the model tree, this can result in a ton of settings appearing in the editor tools window. So after selecting that, we can deselect data access, and now we can return to the application builder, and you can see the output format is now available. So now let's add the output format as an input, and you can see now a user can choose from an HTML or Word doc format when they create their report. So here you'll notice when we included the output format as an input, multiple form objects were added at once. And this is another advantage of adding functionality through the editor tools window. Let's say perhaps we wanted to include another geometry parameter as an input. We can scroll up, and let's say we want to include the thickness as an input. We select that and click Input, and you can see 3 form objects were added at once. A text label for the parameter, the field for the input, and then a unit form object displaying the units for the input. And we can go ahead and move this under the other 2 geometry parameters. And we can select all three of those at once. And let's line it up so it better matches the flow of the other inputs. Alright, so as it stands now, we've included a few other bits of functionality that will be helpful for the user. They can update the geometry and then generate a report of their results. With respect to the geometry, the users at this point can enter any value which we don't want for them to do. For example, inputting a negative number, which we obviously would not want. So what we can do is we can select the input box for the respective field and go into the settings window. And here in the data validation section, we can specify a minimum and maximum value to make sure the user stays within a specified range. So for the thickness, let's set a minimum value of 4 millimeters and then a maximum of 12. And for the error message, so this is what appears when a user enters a value outside of our range. Let's include additional information that will be helpful for them. Instead of just simply saying invalid input, let's also specify, please enter a number between 4 and 12. Alright, so let's test how this works out. Let's enter 3 for the thickness. And if we click Update Geometry, you can see that error message pops up. So now that we've shown how the form editor is used to quickly build basic functionality in an app, let's now turn to the method editor to include more functionality that would be helpful for our users. So when it comes to creating methods, there's a few ways we can do this. We can right-click the methods node and select new method, or the new method button to create a new method completely from scratch. We can use the record method button, which we'll go into a little later on in the video. Or the easiest way is with any form object that has a choose commands to run section in the settings window. You can go down and use the convert to new method button. Currently in our command sequence for the compute button, you can see the commands are to compute the study and to display the temperature results plot. Let's say we also wanted to include an audible notification to our users that the app has finished solving. So we can have a sound play when the simulation is done. To do this, we can go under Libraries, and under Sounds, we can select a sound to be played. Let's use the success sound, and then click Run. And now that's been added to our command sequence. And we can use the Convert to New Method button. And you'll see that command sequence has been replaced with a method, method1. And if we go to this method, we can find the 3 lines of command for computing the study, plotting the temperature results, and then playing the sound. Let's say we also want to play a sound when the simulation app has finished computing but is not successful. So what we can do is we can go in the Editor Tools window, and under Libraries, and under Sounds, we can select a second sound. Let's use the fail sound file, and then click Run, and that's been added to our method. At this point, we want to apply a condition for when to play each sound and indicate when the simulation is successful versus when it fails. To do this, we can use an if-else statement. So I could start to type this out, but instead I can use the Language Elements button to open the Language Elements window. And here you have a variety of different programming language constructs available to be added to our code. We want to include an if-else statement, so we can go under Block Statements and double-click if-else, and you can see the coding for that has been added to our method. So now let's go ahead and place the respective sounds under the proper parts of the statement. Now we need to add our condition, or what makes the simulation a success versus a failure. Let's say that the simulation is successful if the maximum temperature on the busbar domain falls below 500 Kelvin. And let's say the simulation fails if it goes above that temperature threshold. And note that by failure, we don't mean that the simulation app did not solve, we just mean that it failed to come under the specified temperature range, which we consider to be successful. So we can go ahead and enter max temp, and then enter less than 500. And now we need to define our variable max temp, which will be a double. So we enter double max temp, and we want to define this as the volume maximum derived value in our model tree. So we can go in the editor tools window. Let me just make sure I'm in the right location. And I can select volume maximum and then get. So this gets the maximum temperature in the copper busbar domain, which we've assigned our variable max temp to. So note we have an error indicated by the red squiggly line underneath this text. And it says that we cannot convert from a numerical feature, which is this our derived value, to a double. So returning back to the language elements window, let's go ahead and search that. Let's search for numerical feature. And this brings up a few different options. The first option, evaluate to double array 2D, will convert our derived value, a numerical feature, into a double array. So we can double click, and that's been added to our code. And we can move this text, which is our derived value, and place that in the argument for numerical feature. So now this is evaluating our derived value to a double 2D array. So we need to convert our double to a double array. We can simply add brackets next to double. And then to be a better text descriptor of this, let's change the name of this variable to maxTempArray. And then at this point, we still haven't defined our variable maxTemp. So what we'll do now is define our double maxTemp and assign that to the first cell in the array. And make sure we want to add a semicolon at the end. Now, in general, when writing the code for your app, there are some useful features and shortcuts available that you should keep in mind. When writing, you can right-click in the method editor and select Indent and Format to automate making sure your code is properly aligned, having the text be consistently indented and formatted. Additionally, when you come across an error message like here, we can use the Control and 1 keys to correct the error in our code. This could have been used a few times while building the code we just did previously, which would have allowed us to skip several steps. However, we wanted to show you the multiple windows and tools that you can use to generate code for your simulation app, and is thus why we omitted using this shortcut. So now let's go ahead and test this app. Let's change the applied voltage to 80 millivolts and compute that. And as you just heard, the simulation failed since the maximum temperature in the busbar exceeded 500 Kelvin. And if we reduce the applied voltage to 50 millivolts and compute, we hear the success sound play since the maximum temperature in the busbar fell under our temperature threshold. Now we have a sound that plays, but we want to add more functionality to further indicate to our users when the simulation is a failure versus a success. Perhaps we can also reiterate this by changing the display of the plot. So let's exit out of our app and make some changes to our if-else statement. I could start entering code to change the color display of the temperature plot for each part of our statement, but instead, what I can do is click the Record Code button, and you can see that red lines outline the application builder, as well as in the model builder, and this is recording any changes that we make within the model. So to change the color display, I can go under the temperature plot to the surface, and I can change the color table to gray print. This is a good visual indicator of the simulation failing, and then return it to thermal light if it is a success. So now I can go to the developer tab and I can click stop recording, return to the application builder, and you can see the code it generated from what we just did. So now I can add this into both parts of the if-else statement. I just have to make a few changes, remove this line of code right here. And what we can do to expedite this is copy and paste this statement. So this will change the color legend appropriately depending on if it fails or succeeds. And now I can copy this code under the play sound command, and then this part with the gray print color legend under the else part of the statement. Once again, let's test our simulation app. We will increase the voltage again to 80 millivolts and compute. Alright, so we heard that failure sound file play, and we have a more clear visual indicator that this was not a successful simulation. If we enter 50 millivolts and compute again, the sound plays and the color legend changes to thermal light, since the value for the maximum temperature fell under the criteria we specified. So just to reiterate, these are all relatively simple examples of features that we have added to our app as a way to demonstrate how to use all of the tools at your disposal in the application builder. So now that we have finished building our app, let's review the ways that your users can run the app. The test application functionality is a good way to have the user run an app if you have an extra COMSOL multiphysics license and you don't mind the user having access to the entire model. If you still want users to run the app using COMSOL multiphysics, but not through using the test application button, what you can do is you can go to the root node in the application builder, and then under the application section, you can choose when starting with COMSOL multiphysics, run the application, which opens the app alone. So let's demonstrate this by saving the app as basics building app user, exiting out of it. I'm bringing this locally to our desktop. And if we double click, you can see we have the app running and ready for use. However, if we are to right-click and select Edit, you'll see that the user can still access and edit the modeling details of your simulation app. To prevent users from opening it like this, we can once again go to the root node and enable a password to prevent them from editing it. Likewise, you can also set a password to prevent users from running the app. Lastly, we can run the app through COMSOL server. COMSOL Server is a different product altogether, and it's used for distributing apps safely and securely, without users needing to hold a COMSOL Multiphysics license. There are two ways to run your app using COMSOL Server. The first is a COMSOL client for Windows operating systems, which is available as a free download once you have COMSOL Server. The COMSOL client has the same look and feel as the COMSOL desktop, and is thus similar to running the app with COMSOL Multiphysics. The second way to run your app is through a web browser. Note that there is no installation or browser extension required for users to run your app through this means. There are 1D, 2D, and 3D graphics and interactive graphics using the WebGL standard. Both the COMSOL client and web browser are available through COMSOL Server, and each have their own pros and cons. It all depends on what your main needs are. You now have a solid foundation of knowledge on how to build simple and useful apps quickly. There are many more features to implement with the application builder that we could not cover in this video, but you can learn more about them in the Introduction to Application Builder documentation and supplementary videos.